Michael Sizer's in the waiting room right now. He says he wants to talk to you, Jeremy. Should I let him in? All right, we've only done this a few times before, so let's see what happens.
Can we hear you?
Hi, guys. Can you hear me this time?
I can absolutely hear you, Michael. How are you doing tonight?
I'm well, thanks. How are you?
Yeah,
not too bad. Good. Not too bad.
I didn't expect you to take the call right away. If you guys wanted to talk about the JC Pro first, Macro Pro first, by all means, don't let me, get in the way.
Oh no, it's the order we do things really doesn't matter because we can switch it around in post if we had to.
Yeah.
Cool.
So we don't want you to have to wait along. That's not the word. But so what's going on, Michael? You're in Canada, correct? You're calling in from.
Yeah. I'm actually in my little studio, which is at a makerspace in Hamilton, Ontario. Here, where I sort of rent a studio space, which I use more of as an office, and I sort of use the makerspace as my sort of shop.
Oh well, that's very fantastic.
Cool. Yeah, it is because it gives me access to, of course, to stuff that I otherwise just wouldn't have access to, right?
Yeah, so. for sure. I mean, it's at least with me, my local hackerspace, Tampa hackerspace, I think it's $50 a month, and just the amount of tools you have access to is fantastic. I mean, I don't take as much advantage of it as I should because I've got pretty much what I need in my garage, but for somebody, if I didn't have that, it is fantastic.
Yeah, I mean, I use the laser engraver quite a bit. They're setting up a 4x8 CNC router now. So.
Oh, I want one of those.
Yeah, so do I. But at least I can get to play with one pretty soon once they've got it set up here. So.
Well, I used to have a 12x7 CNC router. But that was actually in inches, though. So
that's almost as big as my 3D printer, Jeremy.
Almost. I mean, it was cool for the time, but now I've got
Actually, is that a K40 laser engraver you have, Jeremy, in the background? There's a blue device back there.
Oh.
I can't really see it now, but I've seen it in previous interviews or podcasts.
I do not have a laser engraver in my office. I've got a laser cutter in my garage, so you may have seen that on a YouTube video.
Okay, maybe.
But that's a big red one. The K40s are like a powder blue color.
Yeah, that's right. I got a red and black branded laser, as they because it's who knows what they're. But it's been such a useful tool. I've been using it extensively with the JC Pro Macro 2 when I'm producing that, but we'll get into all that a little bit later. So Michael, what have you been working on these days?
Well, as I've mentioned to you through email, actually, I'm kind of glad to get the opportunity to chat with you guys because you're a couple steps ahead of me. You're with your JC Macro Pro 2, with doing your own production. I've got a product that I'm working on too. I happen to have it right here, but just coincidentally, in the breadboard stage. So I'm doing an air quality monitor circuit.
Very cool.
Yeah, I think so. It's geared toward small farms, so people that have hobby farms for a couple of horses, what have you, when they can't afford, obviously there are big industrial, expensive air quality monitors that you can buy into that integrate with your HVAC and all that, but they're so expensive. So I'm trying to get something that's a little more affordable that people that have a couple of horses or what have you can afford for their barns. That's
a beautiful breadboard. Mine generally don't look at that nicely set up. Looks like you actually put some effort into it.
I cursed in college. I graduated in college in '96, I think it was. But one of our final projects was we had to wire up a circuit. It was quite a big circuit. I think it wasn't quite this big, but it was big. But we were actually graded partially on how neat the board was. And I spent hours and hours and hours on that thing. And I guess the lesson learned there was, if you want to be able to troubleshoot a circuit, you can't just have a whole spaghetti mess of wires, right? Obviously, if it's a few LEDs or whatever, it's no big deal. But the more complicated a circuit gets at the breadboarding stage, you don't want what they call those elephant circuits, right? Where you can't even tell what's connected to what. So even though I cursed at the time, it was a lesson learned. So it's benefiting me today. Although I don't want to admit that to my professor from back then.
Yeah, no, I get that. It's when I first started working, I was like, well, what does it matter if something doesn't look good or whatever? And somebody told me, he said, if something looks, I won't use the phrase he's used exactly, but if something doesn't look very good, people aren't going to be willing to give it a chance. But if it maybe it looks a little bit better and they have a hard time with it to begin with, they're going to give it a little bit more respect. And I think that's one element. And then also, as you said, troubleshooting, if things are labeled, and it's neat, there is some real value to that. And I think that's maybe something you don't, a professor can tell you, or you can learn through experience, I guess.
Yeah, well, especially, and with breadboarding, because they can be a little bit flaky, sometimes the traces don't hold very well and little wires break sometimes. It's just, you want to be able to tell what's connected to what fairly easily.
I was going to complain about breadboards today because I watched Jeremy's video putting his how to put his JC Pro macro pad together, and he was complaining about one of his breadboards that if you put the unsoldered pin headers in, to help line it up for soldering, that sometimes pushes the pins out. That means, Jeremy, you're using one of the crummy Chinese breadboards that doesn't work well. It's too hard to insert things into it. I don't know
you're probably.
I don't know the polite way to say that.
I'm a big fan of cheap electronics.
But all my breadboards are cheap, but half of them are like that. They're all the same price, but half of them came from somewhere else where I can't. You barely push anything into the holes. It's awful.
50% of the time, it works every time.
Yeah.
I remember in college we had the same breadboard for the whole 2 years, and so you'd eventually, of course, some of the tracks stopped working. So I remember you'd take a marker and you'd write on it, say, just scratch it out, so you remember not to use that track anymore. Otherwise, you just
don't use this row anymore.
Yeah, exactly.
That's no good.
Right,
oh, man.
Yeah.
It's amazing how much electronics have come down in price. I mean, imagine at the time, because now it's like, well, breadboard's not working. Just
spend another 50 cents or $1. I don't know what they are this year. I know everything's a little different this year. I haven't bought one in a while.
It's incredible. They like with this project I'm doing. If you had told me in college that in 18 or 20 years you're going to design a circuit that's run by a microcontroller and you're going to plug it into your USB port on your computer. Well, I wouldn't have known what a USB port was, but you're going to plug it into a serial port on your computer and use some fairly simple programming language to get this thing running. I would have thought you're crazy. I thought, microcontrollers like those, that the engineers use microcontrollers, right? So it's amazing the changes. I mean, granted, it's been 20 years since I was last doing it before, but still, it's still pretty amazing how we can, and then of course the fact that you can order stuff for so cheap from overseas.
Oh yeah,
it's just,
Well, what's amazing is, you guys are familiar with the Teensy microcontroller boards, or anyway, the Teensy 4.0. It's got a 600 megahertz processor, I believe, and you can overclock it to like a gigahertz or something, and it's like $20. It's about the size of your index finger, and that just blows my mind because, I think when I started using computers, I mean, that was just an unthinkable amount of power for a desktop PC, and it's and
it's all in one chip.
All in one little chip. It's
all the RAM, all the flash, all the CPU is on one little chip on that board.
Yeah, and it's, I don't know, it's just amazing how things have gone. It's like, and somebody, he was joking, but he said, maybe they just have a alien spacecraft that touched down somewhere and they crashed, and they're just siphoning out the technology little by little.
Along those lines, I was YouTube recommended a video to me the other day, and the EEV blog. I forget the fella's name. He's been blogging for years. Pat, looks like you're familiar with him.
Yeah, I know. I'm trying to remember the guy's name. It's Australian guy, right? That's not his name.
Right.
But,
yeah. Anyway, yeah. So I happened to click on the video, and he was showing how, I don't know if you're familiar with the website LCSC. It's like a branch of JCB. The PCB manufacturer, JCB or
JLC.
JLC.
Yeah, JLC. Yeah. So they have a division with a website called LCSC. And it's sort of like an alternative to Mouser and to DigiKey, right? But it's out of China. And on this video, he was showing a microcontroller. Now, I don't remember any of the specs. It was small. It was an 8-pin little mic. But it was, if I'm not mistaken, I think it was 70 cents. And it was an 8-pin microcontroller. It might have been $1.70 American, but I think it was actually 70 cents. So, unbelievable.
It is. It is unbelievable. So.
Yeah. And Michael, it sounds like you're wanting to switch your design up there from being on a prototype on a breadboard to being a manufactured PCB. Is that correct?
Yeah, that's the goal. So, basically, maybe I'll take a minute and just tell you what it is and what it's about.
Yeah, please.
Please.
Thank you. So basically, like I mentioned earlier, there are very expensive sensor systems you can buy, but with those systems, I mean, just the sensors alone, not even the accompanying circuitry or anything like that, but just the actual sensors themselves can be up in the hundreds of dollars. Now they're very accurate, mind you. I mean, they use their little they call them NDIR sensors. They have little chambers in them basically, and they beam infrared light through them, and of course they know which frequencies are going in, and then based on which frequencies don't pass through, they're able to sense, what is in the air based on the frequency blocking and what have you. Those are very expensive. So along the more consumer and hobbyist line, you guys may have seen them before. I expect you probably have. But for people who haven't, you have these MQ sensor series sensors. They're very different. They're not as accurate, but they're not nearly as expensive. Like these range anywhere from a couple of bucks to, a few of the expensive ones might be $20. And they work differently.
Okay.
They work on the principle of they react. They have internal resistors that react to gases in the air, and they change the resistance based on what gases are in contact with them. One of the challenges, though, is that they're not very specific in terms of, like, so for example, I don't remember specifically which particular sensors sense which gases off the top of my head, but you might get, say, an MQ2, and I don't remember, it might be CO2 it detects, but it may be partially sensitive to methane, for example. And so you'll know that one of those gases is present, but you don't know for sure which one is which. So what I've done is I've kind of gone through a matrix and thought, okay, well, this one senses this, and so does this. So if I monitor both of them, then I know as long as both of them are giving an output, then it's in fact that particular gas, right? Whereas if only one of them, well, then it's methane. So I've designed the circuit based on that. And it runs off an Atmega Atmega 328P, which is the same thing, same microcontroller that's in the Arduino Uno. And I'm a little surprised that nobody has done this yet. So I'm nervous that I'm going to find out somewhere along the way why it's not being done. Maybe.
I know this feeling.
Yeah, but I've got it to the stage now where I've got a physical circuit built. I'm still waiting on 3 sensors and the LCD for the serial port to display. But I'm moving on now to writing the program. So that should happen within a few weeks at the most, I would hope.
Very cool.
And then I'll have a working prototype at that point.
That's awesome. And it's very responsible of you to make an actual breadboard beforehand. I feel like sometimes I'm guilty of just jumping to the PCB and then regretting it occasionally. So.
Well, I knew with this circuit, it's a little too complicated for me to just jump into it, right? But I know what you mean when it's smaller circuits, yeah.
Right. Well, that's awesome.
I've been keeping my eye on various air quality sensors that'll that'll integrate with something like Home Assistant, the home automation stuff I use, the open source home automation stuff.
Right.
That I use at home.
Yeah.
But I don't even know what I want to know about air quality. I don't know enough to know what I'm looking for. That
was one of the challenges too. Was I first had to do some research on what are the specific gases in barns that can accumulate. Which are the ones that you're actually concerned about. So there was some research.
A much more complicated problem than I'm trying to solve.
Well, yeah, yes and no. I mean, it's not a super complicated. That's why, like I said, I'm a bit nervous that I'll find out why it's actually not already in the market, is because it's not terribly complicated. I mean, I had to do my homework, of course, but it's not there's no rocket science involved either. So I'm hoping I'm just lucky enough that I happen to be the first person to you know.
Sometimes
We'll see, I guess.
Somebody's got to be the first, right? So
yeah.
So what is you monitor this air quality? What do you do with that data? What are you looking to? What's your final goal of this project?
Right. So at this point, this particular circuit that I've built here, it will display on an LCD, and I've got some RGB LEDs where they'll go blue to warn you that a certain level is getting high, and red when it's at an unacceptable level. Right.
Right.
But of course, it's not that difficult to put in, a Bluetooth, compatible board or something like that, and then you could have it notify your phone, or even now with, and I haven't looked into exactly how to do this yet, but now with Arduinos in the cloud, it's probably wouldn't be that difficult to have it alert you and send you an email or something, so you don't even have to be on the property. And then ultimately, I think what probably would be the wisest thing would be to integrate it somehow with Wi-Fi, so that you could use a Wi-Fi controlled outlet, and then you could have it turn on say an exhaust fan automatically, right? That would be the ultimate, I think.
That would
make the product.
Can't see me and Pat shaking our heads. Yes, that's a great idea.
This is true. I've been nodding the whole time.
Yeah. Well, I think that would make sense, right? I mean, it's nice to just to know, at least, even if the gases are present, because at minimum you can react yourself. But ideally, I think people would certainly rather that it automatically turned on a fan, or at least notified them remotely. And I don't think
absolutely,
that should be too difficult to arrange.
Yeah, for sure. It's amazing. Just like we were saying earlier, it's amazing the processing power, but it's amazing that the way you were able to integrate everything. I mean, even 10 years ago, you couldn't do this kind of thing. But
no,
and it's
no, that's right. 10 years ago, you would have had to build your own dedicated circuit, and it would be completely independent of anything else, right? Whereas now you can integrate it with and I mean Wi-Fi. I mean, so many properties have Wi-Fi now. I know I do a lot of maintenance work on animal sanctuaries where they have barns, what have you, and it's very common to be able to pick up Wi-Fi from the house in the barn. So, it's just...
And even if you can't, cellular data is getting very inexpensive. There are some very low bandwidth data plans you can get that are just...
That's right.
$10 or less a month to connect to connect your barn up to the Internet of Things.
Yeah, exactly.
Yeah, I was just complaining about this stuff today, Michael and Jeremy, when my friend Alex was here. I was complaining that 20 years ago, if we had these Arduinos and 3D printers and CNC machines back in the time when I was modifying cars, it would have been tremendous. I was talking about, we used to buy this device. It was about $300 that went between the airflow sensor and the computer. And the airflow sensor gave output of frequency.
Okay.
The higher the frequency, the more air was flowing.
Right.
And you just had little knobs like a graphic equalizer to adjust those frequencies to trick the computer into thinking there was more or less air than there actually was. And you could totally do that with a $5, maybe not an Arduino, but a Teensy or somebody would have no trouble in reading a frequency and outputting different ones and doing mappings and things.
Well, yeah, we were talking about that with Nova Spirit on episode 52, I guess, right? So that was, and you said you used to use the Palm Pilot for that kind of thing, which...
Yeah, well, we used the Palm Pilot for just the data logging. It came over a serial port, and you'd log, it would 60 or 80 times a second. It would tell you the injector duty cycle and how much airflow there was, and whether the knock sensor was going off, and how many degrees of timing advance you had, and things like that. But the more expensive device was just to modify one single signal so that we could run more fuel than the computer. You'd put bigger fuel injectors in, but the computer couldn't handle that. It would, you'd run a bigger fuel injector at the same duty cycle you expect to, and you get way too much fuel, and it just doesn't work. You had to rein everything in a bit.
So ultimately, what were you controlling the fuel to air ratio? Is that what you were doing, or?
Yes. That's the ultimate goal, because we would use, our cars had 450 cc per minute fuel injectors, and we would upgrade those to 550 or 650.
Okay.
So we could run bigger turbochargers and pump more air in. And when you put a 650 in instead of a 450, you get 33% more fuel just by default, just by putting it in, because it flows 30% harder. So you'd have to tone that back.
Right. But now you're a drone man, I guess, not a.
Oh, it's so much cheaper flying FPV drones, Jeremy. So much cheaper.
Well, Pat, do you want to talk about Tindy a little bit? I guess.
Sure. Well, before you ask me that, Michael, how are you planning on marketing this? I mean, I don't know. That's a pretty broad question I'm asking, but
yeah, well, it's actually that's something I have. I'm aware that I don't have the background in manufacturing and in marketing, and so that's one of the concerns I have. I was talking recently to a fella I know. The company Zeiss. They make lenses.
Oh yeah.
Well, I happen to know, just by sheer chance, I happen to know someone who's fairly high up, and he had some contacts for me. He said, go and see a friend of his who apparently he's involved with, I guess, if you have an idea or some sort of invention or whatever, and it's not one of those. I know there are all kinds of scams. Bring us your idea, and those are scams. But this guy's apparently legit, where he helps people that are getting started with the new idea to protect themselves and avoid pitfalls. So that's a really broad area that I really know nothing about. I'm going to go consult with him and get myself started. I won't be surprised. I guess if it flies, but it stays fairly small scale, then I have no problem just doing it myself, running it off a website of my own, whatever. If it turns out it's quite popular and more successful than just, a few units here and there, I don't know, maybe I can license it off to someone who knows how to do this stuff. Who knows, right? We'll see.
Yeah.
Right.
Well, that's awesome. Of course, Pat and I think this kind of thing is exciting. It's part of what we do. So Michael, you're going to launch this in a while, but for now, where can we find you? I know you've got a YouTube channel, correct? So
yeah, Maker Mike Sizer on YouTube. Yeah, I've got makermikesizer.com, but I haven't set it up yet. So eventually that'll be set up, and I'll set it up a products page and what have you. But probably YouTube.
Yeah, but don't anybody go there to the website unless it's later.
Yeah.
Unless it's not today. When it's
exactly.
By the time we produce this, he'll have it set up.
Oh, I don't know about that.
Maybe not.
But I've got a few videos up on YouTube now. I've got to get one up soon again. It's been a while since I put one up. So Maker Mike Sizer on YouTube.
Yeah. Well, I think it's interesting. It's not why. I don't know. It's nice to be out there in one form or another, because I feel like that does maybe give you a bit of a built-in audience for this kind of thing, I guess. So, but yeah, anything we could do to help you along, we're, love to hear about this kind of thing. And
thank you. I really appreciate it. And that's the other, just very quickly before I sign off, that's another aspect that, something that's completely new is with social media, the avenues that opens, right? I mean, just the communication and connectivity we have now. Again, back in college, I would have never understood. You couldn't have explained to me what this, what social media would do for us. Right?
Yeah. It's amazing. I mean, this podcast I didn't even start it. A guy named Max Maker. He invited me to do it with him, and he lives in Germany. And it's like, we're good friends now. And I talk to Pat all the time. We get along pretty well too. And then.
I tolerate Jeremy just fine.
It's amazing. We're talking two time zones at least. I guess. Are you Western? Or are you?
I'm in the Central time zone.
No, Michael Otto.
Not me.
Well, it doesn't matter. Anyway, we're all over the place.
I'm Eastern, so I think you and I are in the same. Jeremy, okay. You and I are in the same time zone. Yeah, you match New York, right?
That's right.
Yeah. So
yeah. I think I put New York and Miami time and Frostproof. If you know where Frostproof is, then I'd be very surprised. It's near Orlando. So.
Okay. Well, I really appreciate you giving me the time, guys. I really do. Thank you.
Yeah, well, thanks. It's always fun to meet new people and stuff. So, Anyway, all the best, and hopefully we'll hear from you about your successful project, however you decide to pursue that.
Thank you.
That's what I'm hoping to hear is success.
You and me both. Thanks, guys.
All right.